A true experiment is the best way to maximize internal validity. The key elements of a true experiment are manipulation of the independent variable, comparison between conditions exposed to different levels of the independent variable, and of course random assignment to these conditions. Of course, these elements can be implemented in very different ways. I'll discuss 4 experimental designs that are very common. The simplest design is the two-group design. Participants are randomly assigned to one of 2 conditions, usually an experimental condition where the hypothesized cause is present, and a control condition where it's absent. The independent variable could also differ between the conditions in amount or kind. For example, if we're investigating the effect of male versus female math teachers on math performance of boys, for example. In the two-group design, the dependent variable is measured after exposure to the independent variable to assess the difference between the conditions, which are likely to be similar in all respects due to the random assignment, including their pre-existing position on the dependent variable. Of course, in small groups, randomization doesn't always work. In such cases, it might be wise to use a two-group pretest post-test design, which adds a pretest of the dependent variable before exposure to the independent variable. With a pretest, you can check whether, for example, both groups of boys were equally proficient in math before being exposed to a female versus a male math teacher for a month. This is an especially good idea when maturation forms a plausible threat to internal validity. A pretest also allows the researcher to compare the size of the increase or decrease in scores in the experimental and control condition. For example, we can assess how much the boys' math performance increased due to natural improvement and what the additional effect of teacher sex was. Unfortunately, a pretest can sometimes sensitize participants. The pretest may result in a practice effect, leading to higher scores on the post-test, or it may alert participants to the purpose of the study. Especially if this effect is stronger for one of the conditions, internal validity will be negatively affected. But there's a way to take such unwanted effects of a pretest into account by using a Solomon 4-group design. This is a combination of the two-group design and the two-group pretest post-test design. The experimental and control condition are run twice, once with a pretest and once without. For example, it's possible that the math test isn't very hard to begin with and provides good practice in those math skills that the boys still lack. On the post-test, the boys in both conditions get perfect scores, obscuring any effect that teacher sex might have. If we had 2 other groups of boys that didn't take the pretest, we might see the effect of teacher sex, because these groups have had less practice. Of course, if we find a difference between these groups, it could still be attributable to an already existing difference in math proficiency. But together with the results of the pretest groups, we could come up with a better, more difficult test, showing differences between the 2 pretest groups and 2 non-pretest groups in a follow-up study. Another very common design is the repeated measures design, with one within subject's factor. In this design, all participants are exposed to all levels of the independent variable. They experience all conditions. For example, we could randomly select half of the boys to have a female math teacher for a month, and then a male teacher the following month. And the other half of the boys would be taught by the male teacher during the first month and the female teacher during the second month. The only thing that's really different to the previous between subjects designs is that the random assignment of participants is not to the conditions themselves, because they experience all of them, but to the order in which the conditions are experienced.